Okay, in continuation of problem solving, today we will extend some more techniques of solving problems on center of mass. Let us try one by one. Suppose you take a square lamina of side 2A, divide this into 4 quadrants. These 4 quadrants are equal. If one quadrant is removed, if this quadrant is removed from the square lamina, what would be the shift in center of mass of the square? Originally, center of mass will be at the center. Now the question is, by cutting this piece, this quadrant, how much shift will be there in center of mass? The easiest technique here to do the problem is again this relation, m1 r1 is equal to m2 r2. In the first class itself we discussed about this relation, how to derive it also we discussed. Same technique can be applied here to solve this problem. Now if the mass of each quadrant is m, then total mass will be 4m and mass of the removed portion is m, remaining portion will be 3m. This portion has mass m, this portion has mass 3m. Let the center of mass of the remaining portion be at this point C. Center of mass of the removed portion be at its center at this point O dash. This piece will have center of mass at O dash and remaining 3 quadrants will have center of mass here. If you join them again to get the original square lamina, you will get center of mass at O. So, the combination of 3m and m produces center of mass here. So, you can apply this relation. Here, m1 is 3m, r1 is this distance which we have to find x, and r2 will be this distance which is nothing but this is a, this is root 2a, this is a by root 2. This is a, diagonal will be root 2a, half of the diagonal means root 2a by 2 means a by root 2. So, this is a by root 2 which is r2, m2 is m, m1 is 3m, r1 is x. Apply this relation to get the value of x. 3m into x is equal to m into a by root 2. So, x is equal to a by 6 root 2. So, this is the shift in center of mass. The center of mass of the piece will shift from O to C when you remove this piece. So, the shift will be equal to a by 6 root 2. So, like that whenever some piece is removed, you always consider the mass of the removed piece as m2 and remaining piece as m1, then shift in center of mass can be found using this relation. We already did a few more problems of this type to understand this technique. Let us go for another one. Suppose a body is projected upwards with a velocity 49 meters per second from the ground. A body is projected with a velocity 49 meters per second from the ground. Simultaneously, another body is dropped which is identical to this body, is dropped from a height 98 meters. So, first one body is projected with a velocity 49 meters per second, another is dropped from a height 98 meters. The point here is these two are identical in mass. So, if this is m, this will be m. So, when this is dropped, simultaneously this is projected, they will meet somewhere in the middle, somewhere in between their path, and they stick together. They collided and stick together. Afterwards, the combined piece traveled and falls on the ground. So, what is the total time taken for all this process to take place? One particle is thrown upwards, another is dropped. Both are acting simultaneously, both are taking place simultaneously. So, when the upper one is falling and the lower one is projected upwards, they will meet in between somewhere here, and the combined piece stick together and travel upwards according to the problem. Again it goes up sometime, its velocity becomes 0 and then comes back to the ground. The question is, what is the total time taken for this process to take place from the beginning? From the beginning, what is the total time of the journey of the pieces? Let us do this using the concept of center of mass. Normally using kinematics also this can be done, but using center of mass this can be done in a better way. First of all, if this mass is m, this mass is also m, because it is given that they are identical. Now their center of mass will be exactly at the center of the two pieces. Initially this is at a height 98 meters, this is 0 height. So center of mass will be here at a distance 49 meters from the ground. Center of mass of the two pieces will be at a distance 49 meters. Now from here you can assume that the motion of the center of mass started from here only. The moment the motion of the particle started, center of mass motion also started. What is the initial velocity of center of mass? To find the initial velocity of center of mass, apply this formula. Velocity of center of mass is equal to m1 v1 plus m2 v2 by m1 plus m2. If you apply this relation, you will get the velocity of center of mass initially. m1 is m, v1 is 49 plus m2 is m. Initial velocity for this body is 0 because it is dropped. Dropped means initial velocity is 0 by 2m. So what we will have is 24.5 meters per second is the velocity of center of mass of the two particles. Initial velocity of center of mass or velocity of center of mass at t equal to 0 is 24.5 meters per second. Vc at t equal to 0 is 24.5 meters per second. Now, what is the acceleration of center of mass? Acceleration of center of mass is acceleration of this two particle system. What is the acceleration of the two particle system? Its acceleration is g, its acceleration is g. Both the g's are acting downwards. The center of mass also have the acceleration g only. There is no difference in that. So, acceleration of center of mass is g. That is 9.8 or whatever the value, you can take 10 also. 10 meters per second square. Acceleration of center of mass is 10 meters per second square. Velocity of center of mass, initial velocity of the center of mass is 24.5 meters per second. Now it is at a height 24.5 meters from the, it is at a height 49 meters from the ground. So it is equivalent to a particle projected upwards from a height h. Suppose if a particle is projected from a height h like this, its equation of motion is, we know that minus h is equal to ut minus half gt square. This equation is used to find the time taken for this particle to reach the ground when it is projected upwards with a velocity u from the height h. From a height h, if you throw a body upwards with a velocity u, then the time taken for it to reach the ground is given by this equation, which can be applied here for the center of mass case also. Then how to get the answer here, how to solve this problem? We use this equation only, considering the two bodies as single body which is representing center of mass, whose initial velocity is 24.5, whose acceleration is 10. Then minus h means minus 49 is equal to u is 24.5 minus h is equal to ut minus half gt square. It is better to take g 9.8 here because all are in multiples of 4.9. You take half g t square. So this is equivalent to minus 49 is equal to 24.5 t minus 4.9 t square. This is the equation. Divide the total equation by 4.9, you will get to minus 10 is equal to 5t minus t square, or t square minus 5t minus 10 is equal to 0. So from this equation, from this quadratic equation, you can get the time of journey of the center of mass. this is t equal to minus b plus or minus root of b square is 25 plus 40 by 2. So this is equal to 5 plus only you take minus means total answer will get minus, time cannot be negative, so you should neglect the minus root here, plus only you take plus root of 65 by 2. If you approximate this to root of 64, it will be 8 plus 5 13 by 2, so approximately 6.5 seconds is the answer. So the two bodies will reach the ground after 6.5 seconds from the beginning of motion of both the particles. So this is a different method for solving this kinematics problem. This is previously given in IIT for something like 7 marks or 8 marks, which is given as a descriptive type question, expecting it to be done in a big way, but it can be done so simply using the concept of center of mass like this. Now let us try to do another problem. Suppose there is a metal rod of length L. A metal rod of length L is standing vertically on a smooth ground. Smooth ground means there is no friction here. On the ground there is no friction. So center of mass will be here at a height L by 2. When this rod is left free, if it is given a small jerk, can you guess how it moves? If it is given a small jerk, means almost force equal to 0, then you can make it to fall. When it falls, how the center of mass moves? If the body is like this, if it is falling, if the friction is absent on the surface, it falls like this. It falls like this. So when it falls like this, how the center of mass is moving? Logically, you already know that if external force is 0, force on center of mass is 0. If external force on the rod is 0, here center of mass is not experiencing any force. When it is not experiencing any force, it should not move. Any force means in the horizontal direction. Center of mass is not moving in the horizontal direction because FCM in the horizontal direction is 0. In the vertical direction, mg will act. Mg will act at the center. So only force acting on the center of mass is mg. External force acting is mg, which is acting vertically downwards. There is no force in the horizontal direction, so we won't expect it to move in the horizontal direction at all. We expect it to move in the vertical direction only. Therefore, the center of mass motion should be along a straight line. It is moving along a straight line like this, means when the rod falls like this, center of mass falls like this. So everywhere center of mass moves like this only. It is in a straight line. So the path of the center of mass here is a straight line because external force acts only along the straight line downwards.